episode of the mathematics video series is on degrees of freedom and finding critical values of t from a t-table. You can't get around it. The concept of degrees of freedom is embedded in statistics and seems to show up throughout the course. Yet, the plaguing question students always ask is, what are degrees of freedom? The number of degrees of freedom, commonly written as df, is the number of scores that can vary in the statistic. What this means is, let's say there are 5 tests required for your class, and we know that your average score you want to be is 90. So the first 4 tests can be different, or they can vary, but the last one has no choice except to be whatever will give you the result of 90. For example, if the first 4 scores are 100, 90, 80, and 80, but the result has to average 90, the last score cannot vary. There is only one option, and that is for the last score to be 100. Thus, there is freedom in the first 4 scores, but not in the last one. There's no freedom for that score to be anything other than 100, if the mean must be 90. So the number of degrees of freedom in this example is 4. In this statistics class, most of the time the number of degrees of freedom is n-1. But there are cases where the number of degrees of freedom is different, and there are uses for degrees of freedom that extend beyond statistics. For our purposes, to compute a sample variance, the degrees of freedom is n-1. Recall that the formula for the sample variance is this. Notice that whichever formula you use to find this variance, n-1, is in the denominator. This is your degrees of freedom. So if a data set has n observations in a single sample, there are n scores, and we use n-1 degrees of freedom to estimate variability. However, if there are 2 samples, you add together the number of observations of each, or this. Thus, the degrees of freedom for 2 samples is this. Now that we have a sense of degrees of freedom, let's determine how to look up a value on a t-table. First, notice that the left column says degrees of freedom. This will be n-1 for a 1 sample test. So if n is 30, the number of degrees of freedom are n-1 or 29. And if n is 8, the number of degrees of freedom are n-1 or 7. Next, notice that across the top, you have one set of values for a 1-tail test and another set of values for a 2-tail test. Also notice that if you have a 2-tail test with 0.10 in 2 tails, then there's 0.05 in 1 tail, or half. Let's say there is a 2-tail test with 0.05 in 2 tails, then there's 0.025 in 1 tail. Now we are ready. Armed with the number of observations n, whether it's a 1-tailed or a 2-tailed test, and the area in the tail region, we can look up a score. Let's say you have n equals 20 in a 2-tailed test, with 0.10 in the 2 tails. First, find the degrees of freedom, which is n-1 or 19. Go down the left column to get the degrees of freedom of 19, and across the top we see the area in 2 tails of 0.10. Go down that column and across the row with degrees of freedom of 19 to get the value of 1.729. Now let's try one more. We're given a 1-tail test with n equals 8, and the area in 1 tail of 0.025. The degrees of freedom are 7. So go down the first column to 7 and across the top row to get the location where it says that the area in 1 tail is 0.025. Find the intersection of those two. The result is 2.365. That's it for this lesson. George Washington Carver once said, "Education is the key to unlock the golden door of freedom." You now have the freedom to do your homework on t-tests. Until the next episode, I wish you the very best. This is Rachel Winston, signing out.